So the first theorem, the important theorem from derivatives, is the chain rule. It states that if y is a derivable function of u, and u is a derivable function of x, then the chain rule states that dy by dx is equal to dy by du into du by dx. Okay, see the proof. This is very important result from calculus. So it is given that y is a derivable function of u and u is a derivable function of x. For the independent variable is x. So we suppose delta x. Let delta x be the small increment in x, because it is the independent, so it changes first. Small increment in x, and now it is given that u is a function of x, so u changes accordingly, and delta u comma delta y be the corresponding increments, because as x changes, u changes, and as u changes, y also changes. So I may suppose here delta y comma delta u or delta u comma delta y be the corresponding increments in u and y respectively. Okay, so these are the increments needed to define the derivatives. Now y is a derivable function of u means y is a derivable function means its derivative exists with respect to u, is a derivable function of u. So we can write that the derivative of y with respect to, that is dy by du, and which is defined in terms of increments as the limit of delta y by delta u as delta u tends to 0 exists. Okay, also it is given that u is a derivable function of x. U is a derivable function of x. And so I may write, therefore, by the definition of derivability, we can write du by dx is equals to limit of delta u by delta x as delta x tends to 0 exists. Now we have to express the derivative of y with respect to x in terms of u and x. So like this. Now I may write delta y by delta x is equal to, just multiply and divide by delta u, so we get here delta y by delta u into delta u by delta x. Okay, so just I have multiplied the numerator and denominator by delta u. Now taking limit as delta x tends to 0, we get, because we have to find the derivatives, and for that purpose we have to take the limit as delta x tends to 0 comma, we get on both sides, it is limit of delta y by delta x as delta x tends to 0. Now take the limit of each term on the right side, delta y by delta u as delta x tends to 0 into similarly limit of delta u by delta x as delta x tends to 0. Now on the right side we can find that limit of delta u by delta x tends to 0 exists, and for the existence of this delta y by delta u I should have delta u tends to 0, and for that we find what happens to delta u as delta x tends to 0. Now I may write limit of delta u as delta x tends to 0 as limit of delta u by delta x into delta x, multiplying and dividing by delta x, we have this thing, and this limit comes to be du by dx into limit of delta x as delta x tends to 0 is 0, so we have this. That is, I may write as delta x tends to 0, this delta u also tends to 0, and by replacing this delta x by delta u on the right side we get here limit of delta y by delta x as delta x tends to 0, it is equal to limit of delta y by delta u as delta u tends to 0 into limit of delta u by delta x as delta x tends to 0. Now I observe that limit on each limit on right side exists, since each limit on RHS exists, so LHS also exists. Each term on the right side exists, RHS exists, so does LHS, and it is equal to dy by dx, the limit on the left side. So thus we have the result dy by dx is equal to dy by du into du by dx. Okay, that's the proof.